challenge is to find x, and the key is to turn equal lengths into equal angles. The four sides, A to B, B to C, C to D, and D to A, are equal. The three sides, BP, BQ, and QP, are also equal. That lets us pair AB with BP and BC with BQ. Start with triangle ABP. Because AB equals BP, this triangle is isosceles. The angles at A and P are therefore equal, so each one is x degrees. Now we can write x plus angle ABP plus x equals 180. Rearranging gives angle ABP as 180 minus 2x degrees. The second triangle follows the same structure. Because BC equals BQ, triangle BCQ is isosceles. The angles at C and Q are both x degrees. So x plus angle QBC plus x equals 180. This gives angle QBC as 180 minus 2x degrees. There is one more angle at B that we need. Triangle PBQ has three equal sides, so it is equilateral. Therefore, angle PBQ is 60 degrees. Now consider the four angles of the rhombus. The angles at A and C contribute 2x altogether. So, angle ABC plus angle CDA plus 2x equals 360. Opposite angles in a rhombus are equal, so angle ABC equals angle CDA. That means twice angle ABC plus 2x equals 360. Rearranging gives twice angle ABC equals 360 minus 2x. Dividing by 2 gives angle ABC as the quantity 360 minus 2x divided by 2. This simplifies to 180 minus x degrees. The opposite angle at D has the same value. This is the point where all the angle expressions connect. At B, the two outer angles and the 60-degree angle combine to make the complete angle ABC. So, 180 minus 2x plus 60 plus 180 minus 2x equals 180 minus x. Collecting the terms gives 420 minus 4x equals 180 minus x. The remaining algebra is short. 240 equals 3x. So 80 equals x. Therefore, x equals 80 degrees. The key idea is that the equal side lengths create two isosceles triangles, and their angles fit together inside the angle of the rhombus.